Hi, this is a video where we're going to talk about how the basic transformations impact the graphs of basic functions. We're going to take a look at the quadratic function first. As we know that f of x equals x squared has the domain of all real numbers, and the range is going to be from 0 to 2. And we're going to take a look how each one of those things is going to be affected by a particular transformation or combination of transformations. So what do we have here? This is a horizontal shift of 2 units to the right. The domain, by the way, the domain will never be affected for this function because it's always going to be all real numbers. You don't even have to think twice. So if you ever have a question that involves transformations of a quadratic function, you can simply write that the domain is always going to be all real numbers. It's impossible to affect that, but range can be. Okay, so does the range get affected? We have a horizontal shift. Range is your y values. Y values do not get impacted, so our range remains the same. Example 2, we have a vertical shift of 4 units up. We do remember what I mentioned just a moment ago, and the domain is going to be all real numbers. So what's happening with range here? We're shifting the graph 4 units up. The lower boundary here is going to shift 4 units up. So instead of 0 to infinity, it's going to be 4 to infinity. Negative x squared minus 1. You need to be careful. There are two things happening here. It flips over the the x-axis, and then it shifts 1 unit down, right? So while the domain obviously remains the same, what's going to happen with the range here? Well, first of all, when you flip it, the range is going to flip from 0 to infinity to negative infinity to 0. That's after you flip. And then you shift it 1 unit down, so this boundary here, while this one's going to stay negative infinity, this boundary here will drop 1 more unit, and the range here is going to be negative infinity to negative 1. Remember, the graph flips, you're going to flip the boundaries and change the infinity to negative infinity. What happens here? We have a horizontal shift of 1 unit to the left. We already know that one's not going to change anything, and when we have a reflection about the x-axis. So really the only thing that's going to make any changes to anything here is the vertical flip. So the domain is the same, and the range here, the range is going to be from negative infinity to 0. We're going to do a similar thing now with absolute value function. The absolute value function has the same domain, same range, somewhat of the same behavior. So we are going to apply that and see how it's going to impact everything. The domain, is going to stay the same all the time. So we don't even have to think. I can just write that the domain is going to be all real numbers for every single one of them. It's impossible to change that. This is a horizontal shift of 1 unit to the left. Does not impact the y values, only the x values, and the range is going to be still 0 to infinity. Here you have a horizontal shift of 9 units to the left and the vertical shift 7 units down. This is the only value that's going to make any changes. We're going to drop 7 units. So our range is going to go from negative 7 to infinity. What do we have here? This is a flip about the x-axis and the shift 7 units down. Very similar to what we just saw with the quadratic function. Our range here is going to be then, when we flip about the x-axis, it's going to flip to negative infinity to 0. And when you shift it 7 units down, our result is going to be from negative infinity to negative 7. Here we have a horizontal shift 3 units to the right. That's not going to impact anything. Then we have a vertical flip about the x-axis, and we're going to move it 40. Oh, I'm sorry. This was. Oh yeah, that's right. This one's going 4 units up. Right? Almost got myself confused. It happens to all of us. Okay, we know this is going to flip from negative infinity. This one doesn't change anything. This one's going to flip from negative infinity to 0, and this one's going to flip, move 4 units up. That means we're going to have it from negative infinity to positive 4. Only the actual numerical boundary is going to change, not the infinity. Right. Now, last thing, we're going to take a look at the square root of x function, because that function actually has restricted domain and range, and that's going to be impacted by transformations in various forms. What do we have here? This is a vertical shift of 7 units up. The domain is not going to change because this is impacting the y values. The domain is the x values, so that one's going to stay the same. And then the range is going to shift 7 units up, so it's going to go from 7 to infinity. Here we have a shift of 6 units to the right, and then down 2. In this case, both domain and range will be impacted. For the domain, we're going to move the value 6 units to the right. It's going to go from 6 to infinity. And for our range is going to go 2 units down. It's going to go from negative 2 to infinity. 3 transformations here. A horizontal shift 2 units to the left. A flip about the x-axis. And 6 units down. Let's be careful. So the horizontal shift is the only thing that's impacting the domain. We can write the domain now. As going from negative 2 to infinity. So what's going to happen with the range? Because of the transformation, this range is going to flip from negative infinity to 0, and you're going to shift it 6 units down. So it's going to be from negative infinity to negative 6. Okay. We need to be very careful with these types of problems because it says negative x plus 2. This is actually where what you can do if you get a little confused, because negative here changes everything. So this is actually not going to be a horizontal shift 2 units to the left. It's actually going to be interpreted as a horizontal shift 2 units to the right because of the negative. So we flip here about the y-axis. We shift because of the negative 2 units to the right, and we are also going to go 1 unit up. Another way you can always view that is if you write the inequality, because you want negative x plus 2 to be greater than or equal to 0, and you can solve that, and this will help you figuring out the domain of this function, which can verify what you come up with. Right, so when you flip about the y-axis, you're going to go for the domain from negative infinity to 0, and then you're going to shift it 2 units to the right, and we are going to get from negative infinity to 2, and our range will be, we're going to move it 1 unit up, so it's going to be from 1 to infinity. And this is all. Hope this helps.